Today we'll introduce the idea of a sequence. Well, a sequence, what is it? Well, it's a list of numbers, and sometimes sequences can be described using a rule. Other times it's simply a list of numbers and we don't have a rule. There's two types of rules that we see. There's explicit rules or explicit formulas, which we'll look at in this first example, and there's a type of rule called the recursive rule, which we'll see in the next. So, here we go. Find the first 5 terms in the 50th term for b sub n equals 2 minus 1 over n squared. So a sequence is a rule. It's a list of numbers that generates, or it's a rule that generates a list of numbers where n is usually, I'm not going to say always, but usually an integer. So I want the first 5 terms. So what that's saying is I want b sub 1, b sub 2, b sub 3, b sub 4, and b5. The subscript tells us the term. So how am I going to do that? Well, I'm going to put the n into this explicit rule. What an explicit rule means is we can plug the n value that we want directly into the rule and get the term. So 2 minus 1 over 1 squared, so the first term is 1. b2, 2 minus 1 over 2 squared, so this would be 1 3/4. b3, 2 minus 1 over 3 squared, 1 8/9. 2 minus 1 over 4 squared, 1 15/16. 2 minus 1 over 5 squared, 1 24/25. And we could keep generating terms this way. A lot of times you'll see sequences given as just a list. 1 3/4, 1 8/9. And if I just stop listing them here, this is what we call a finite series. It stops. But if I were to put a ... at the end, now it is an infinite sequence. It goes on and on forever. The domain for this would be n is greater than or equal to 1 within the set of integers. If it goes on forever, it would be any integer greater than 0 but up to infinity. So explicit rule allows us to find any term. So if I want the 50th term, well, b50 is going to be 2 minus 1 over 50 squared. And this is going to be 1 and 2,499 over 2,500. So that would be the 50th term in the sequence way out over there. A recursive formula looks different. A recursive formula requires 2 pieces of information to find our terms. And the 2 pieces of information are a start value and a rule or a relationship. And the relationship is between a term and a term that came before it. So here I want the first 5 terms. Again, we're already given b1. b1 is 5. b2, using the rule, we're going to do 2 times bn minus 1. Well, if n is 2, this number right here, the bn minus 1 would be b1 plus 3. This bn minus 1, the 1 less than n, that just means previous term. So this is going to be 2 times 5 plus 3, which would be 16. b3 will be 2 times bn minus 1. Well, n here is 3, so it's going to be 2 times b sub 2 plus 3, 2 times 16 plus 3. 2 times 19 is 38. So my sequence that I'm generating is 5, 16, 38. Let's find B4. Pause the video right now, and once you find B4 and B5, and add them to this sequence. Alright, so hopefully you have 2 times B3, because that's the previous term, plus 3. This is 82. B5 is going to be 2 times B4 plus 3. And this last term, the 5th term, will be 170. Now, how am I going to find the 20th term? Well, to find the 20th term, we would need the 19th term. But to find the 19th term, we need the 18th term. To find the 18th term, we need to know the 17th term. So I hope you can see the drawback of a recursive rule. To find any term that's far out there, you need everything before it. That can be a real pain if you're out in the 20th term or 50th term. Heaven forbid I wanted the 100th term. It would be a nightmare. We can use the calculator to help us out. What I'm going to do is I'm going to push 5 and then enter. And now I'm going to type 2 times answer plus 3. So I'm taking the answer from the line above, the previous term, adding 3 and then multiplying by 2. So there's term 2, 3, 4, 5. Those are the ones I found by hand. Now I got to get up to 20, so I'm just going to have to keep pushing enter. That's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's the 20th term. Now the drawback is if you make a mistake counting, you have to press clear and start over. And, well, that's just a dreadful pain, but it's the life we live in with a recursive rule. Explicit rules are wonderfully nice because if I want the 100th term, I put 100 into the rule and I have it. Some sequences can only be described by recursive rules, though. Some sequences can be described by recursive rules and explicit rules. And we're going to play around with them and focus a lot of energy on explicit rules for something called geometric sequences and arithmetic sequences.